Paralleling conductors in residential wiring can introduce several safety hazards and code violations. The situation described involves two 10/3 Romex cables paralleled and connected to a 60-amp breaker in a subpanel which supplied a kitchen range after the cooktop and oven were replaced by a freestanding range. There are a number of code references and dangers to point out. Firstly, regarding 210.19 ATWR, branch circuits must be rated for the maximum possible load served. Secondly, 240.15b3 specifies that overcurrent devices must protect all ungrounded conductors. Thirdly, 300.13 prohibits the use of splices in branch circuits, unless specifically permitted elsewhere in the code. In this case, paralleling conductors is generally not permitted for residential circuits of this type. One of the dangers is overheating and fire risk. Paralleling conductors increases the current carrying capacity, however, it does not increase the insulation value of each conductor individually. This can lead to overheating and potential fire hazards, especially if the current draw exceeds the ampacity of the individual 10/3 cables. Another danger involves increased electrical magnetic fields, or EMFs. The twisted ends of the two wires in close proximity can create EMF hotspots, which some studies have linked to health concerns. There is also the issue of voiding of warranties. Tampering with the electrical system may void warranties on electrical appliances and potentially on the home itself. The conductors in question are 10/3 Romex cables. The number 10 indicates the gauge of the wire, which is American wire gauge, or AUG. The number 3 indicates the number of current carrying conductors within the cable assembly, in addition to a ground wire. In a 10/3 Romex cable, you would typically find a black wire, a red wire, a white wire, and a bare copper ground wire. The black and red wires are typically used as ungrounded or hot conductors, the white wire is the neutral conductor, and the bare copper wire is the equipment grounding conductor. Romex is a brand name for non-metallic sheath cable type NMB, which is commonly used for residential wiring. It consists of two or more insulated conductors enclosed in a non-metallic outer jacket. The insulation and jacket are typically made of polyvinyl chloride or PVC. The ampacity of a 10 AWG copper conductor, when used in type NMB cable, is typically limited to 30 amps according to the NEC, specifically Table 310.15b16, formerly Table 310.16 in earlier code editions like the 1999 code. This rating is based on the assumption that the cable is installed in a typical residential environment with an ambient temperature of 30 degrees Celsius or 86 degrees Fahrenheit. The NEC specifies that conductors must be protected against overcurrent in accordance with their ampacities per 240.3d. In this case, a 10 AWG copper conductor should be protected by a 30 amp overcurrent device, such as a circuit breaker or fuse. Connecting two 10/3 Romex cables in parallel to a 60 amp breaker violates this requirement, as each individual conductor is only rated for 30 amps. The use of a 60 amp breaker does not provide adequate protection for the individual 10 AWG conductors. It's important to note that the NEC prohibits the paralleling of conductors smaller than 1/0 AWG in most situations. This means that conductors smaller than 1/0 AWG cannot be used in parallel to increase current carrying capacity. Section 310.10h details the specific conditions under which conductors can be run in parallel. The described scenario violates several of these conditions. When conductors are run in parallel, they must be the same length conductor material, insulation type, and be terminated in the same manner. In this case, even if the 10/3 Romex cables met the other requirements for paralleling, they are still too small to be used in parallel per code. It is also important to emphasize the importance of proper termination of conductors. NEC section 110.14 requires that conductors be properly terminated to ensure a reliable and safe connection. This includes using appropriate connectors and terminals that are listed for the specific type and size of conductor being used. The practice of twisting the ends of two wires together and placing them under a single screw terminal is not a proper termination method and can lead to loose connections, overheating, and arcing. The dangers of improper termination of conductors are significant. Loose connections can cause increased resistance, which leads to heat buildup. Over time, this heat can damage the insulation on the conductors and potentially cause a fire. Arcing can also occur at loose connections, which is a dangerous electrical discharge that can ignite nearby materials. The purpose of an overcurrent device, such as a circuit breaker or fuse, is to protect the conductors from overcurrent conditions such as short circuits or overloads. When an overcurrent occurs, the overcurrent device will trip, interrupting the flow of electricity and preventing damage to the conductors and equipment. In the described scenario, the 60 amp breaker is not providing adequate protection for the 10 AWG conductors. If an overcurrent condition were to occur, the 10 AWG conductors could overheat and potentially cause a fire before the 60 amp breaker trips. The homeowner produced a receipt from 2002 which showed the remodeler's charge for rewiring the 30 amp cooktop and oven circuits into one 60 amp circuit. This information is relevant because it provides evidence that the improper wiring was done by a contractor who should have been familiar with electrical codes and safety practices. The fact that the work was done in 2002 means that it was subject to the electrical codes in effect at that time, which would have likely prohibited the paralleling of 10 AWG conductors. The buyer would like a fair assessment of the electrical system, and it is essential to provide them with accurate and complete information about the dangers and code violations associated with the paralleled conductors. It is also important to explain the potential consequences of leaving the improper wiring in place, such as the risk of fire, electrical shock, and voiding of warranties. You are not overreacting. The paralleled conductors and unsafe connection under the breaker terminals pose serious electrical safety hazards. The fact that the home inspector missed this issue raises concerns about the thoroughness of the original inspection. It would be prudent to recommend that the buyer have a more comprehensive electrical inspection performed by a qualified electrician to identify any other potential issues. Some of the possible remedies include replacing the dangerous circuit with two separate 30 amp circuits for the kitchen appliances. This would involve running two new 10/3 Romex cables from the subpanel to the kitchen and installing two 30 amp breakers in the subpanel. This would ensure that each appliance is supplied by a properly sized circuit and that the conductors are protected by the appropriate overcurrent device. Hire a qualified electrician to perform the work to ensure compliance with all applicable codes. A qualified electrician will have the knowledge, skills, and experience to properly install the new circuits and ensure that they meet all applicable codes and safety standards. Inform the homeowner of the EMF concerns and suggest consulting with a health professional to assess any potential risks. While the scientific evidence regarding the health effects of EMF is still debated, it is important to inform the homeowner of the potential risks and allow them to make their own informed decisions. Emphasize to the homeowner that this issue is a significant safety concern that requires immediate attention. While it may be an expensive repair, it is essential to ensure the electrical safety of their home and family. It is also important to document all of the code violations and safety hazards in a written report and provide a copy to the homeowner. This will provide them with a clear record of the issues and the recommendations for correcting them. It is also important to consider the liability implications of the improper wiring. If a fire or other incident were to occur as a result of the improper wiring, the homeowner could be held liable for damages. By documenting the code violations and safety hazards and recommending that they be corrected, you can help to protect the homeowner from potential liability. In addition to the specific code violations and safety hazards discussed above, there are some other general electrical safety tips that you can share with the homeowner. Firstly, never overload electrical circuits. Overloading a circuit can cause the wires to overheat and potentially start a fire. Be sure to use the correct size and type of extension cords. Extension cords should be used temporarily and should not be used as a substitute for permanent wiring. Inspect electrical cords and plugs regularly for damage. Damaged cords and plugs can pose a shock hazard. Replace any damaged cord or plugs immediately. Keep electrical outlets and switches dry. Water can conduct electricity and can pose a shock hazard. Do not use electrical appliances near water. If an electrical appliance falls into water, do not touch it. Disconnect the power at the breaker or fuse box first. Install ground fault circuit interrupters, or GFCIs, in areas where water is present, such as bathrooms, kitchens, and outdoor areas. GFCIs are designed to protect against electrical shock by interrupting the flow of electricity if a ground fault is detected. Test GFCIs regularly to ensure that they are working properly. Have a qualified electrician inspect the electrical system regularly. A qualified electrician can identify potential problems and make recommendations for repairs or upgrades. The NEC is a comprehensive set of standards for electrical wiring and equipment. It is updated every 3 years, and it is important to stay up to date on the latest requirements. The NEC is not law, but it is widely adopted by state and local jurisdictions. Many jurisdictions require that all electrical work be performed in accordance with the NEC. The purpose of the NEC is to provide a safe and practical standard for electrical installations. By following the NEC, electricians can help to ensure that electrical systems are installed safely and that they will operate reliably. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It also includes requirements for specific types of occupancies, such as residential, commercial, and industrial buildings. The NEC is a complex document, and it can be difficult to understand all of the requirements. It is important to consult with a qualified electrician if you have any questions about the NEC or electrical safety. In summary, the described situation presents significant electrical safety hazards and code violations. The paralleling of 10/3 Romex cables to supply a 60 amp circuit is not permitted by the NEC and can lead to overheating, fire, and electrical shock. It is essential to correct this dangerous wiring as soon as possible to protect the safety of the occupants of the home. The homeowner should hire a qualified electrician to inspect the electrical system and make the necessary repairs. The electrician should be familiar with the NEC and should be able to ensure that all electrical work is performed in accordance with the code. By taking these steps, the homeowner can help to ensure the safety and reliability of their electrical system. The assessment made in this case is not an overreaction. The situation warrants immediate attention and correction by a qualified electrician.